Neural architecture is undergoing a radical paradigm shift as frontier model capabilities move from centralized cloud dominance toward localized, sovereign small language models for absolute data governance. Enterprise leaders are now prioritizing model orchestration that guarantees digital resilience by shifting critical reasoning tasks from massive black box architectures to transparent and highly efficient localized frameworks. We are entering an era where the strategic integration of localized infrastructure ensures that proprietary intelligence remains within the organizational perimeter while maintaining competitive frontier performance at scale. This roadmap for 2026 focuses on the architectural evolution of artificial intelligence through the lens of supply chain transformation and the rigorous protection of enterprise intellectual property assets. By the end of this deep dive, you will possess a comprehensive blueprint for deploying high-performance language models that prioritize sovereign digital trust and strict regulatory compliance. Our analysis leverages state-of-the-art benchmarks and global research to demonstrate how specialized intelligence outpaces generalist cloud models in high-stakes professional and industrial environments. Research from the NIST AI Risk Management Framework establishes the gold standard for securing enterprise systems through ethical protocols and robust architectural validation of localized neural networks today. The European AI Alliance and the official EU AI Act are currently shaping the global landscape for trustworthy intelligence by mandating high levels of transparency and local control. In France, Mistral AI is pioneering efficient language models that provide sovereign capabilities for organizations seeking to maintain absolute autonomy over their digital assets and core operational processes. Across North America, Hugging Face provides the technical foundation for demystifying architectural shifts, allowing researchers to benchmark small models against the largest centralized cloud clusters with high precision. The Brazilian Internet Steering Committee emphasizes the critical importance of data sovereignty in Latin America as nations strive to build resilient digital economies independent of foreign cloud providers. In Asia, Baidu and SoftBank are accelerating the intersection of robotics and multimodal intelligence while India scales adoption through practical governance frameworks designed for the diverse global south. Leading academic research published on the ArcSIF platform suggests that reasoning agents are becoming increasingly compact, allowing for sophisticated enterprise decision-making on consumer-grade local hardware resources. These global trends indicate a massive decentralization of intelligence where the value of a model is measured by its precision and privacy rather than its raw parameter count alone. Modern benchmarks reveal that models ranging from 7 billion to 14 billion parameters often achieve parity with massive cloud architectures when fine-tuned for specific vertical domain expertise. Organizations are finding that the diminishing returns of massive parameter counts do not justify the exposure of sensitive data to external third-party vendors in the current landscape. Architectural efficiency allows for significantly lower latency and reduced operational costs while maintaining the frontier capabilities required for sophisticated natural language processing and complex logical reasoning tasks. Quantization techniques further enhance the accessibility of these localized models by allowing high-precision inference to occur on standard enterprise server hardware without requiring massive GPU clusters. Comparative analysis shows that specialized small language models can outperform generalist cloud giants in tasks involving proprietary terminology and internal organizational context that cloud models never see. The shift toward compact intelligence is driven by the need for sustainable industrial AI that integrates seamlessly with existing European manufacturing and global supply chain management protocols. Evaluating these models requires a focus on reasoning accuracy and task-specific performance rather than the broad but shallow knowledge bases typical of trillion-parameter frontier cloud models. Strategic planning now involves selecting the optimal model size that balances computational requirements with the necessary depth of understanding for specific enterprise automation and decision support pipelines. Successful enterprise adaptation relies on building automated pipelines for the continuous fine-tuning of localized models, using the unique intellectual property generated within the daily corporate workflow environment. This process ensures that the resulting artificial intelligence reflects the specific values and strategic goals of the organization while preserving the confidentiality of the underlying training datasets. Local fine-tuning enables the model to grasp subtle nuances in internal documentation and historical project data that are essential for providing accurate and relevant strategic insights. Data engineering teams must focus on the curation of high-quality proprietary datasets to ensure that the fine-tuning process enhances the model accuracy without introducing unwanted biases. Modern frameworks allow for parameter-efficient fine-tuning, which minimizes the computational overhead while maximizing the impact of organizational knowledge on the performance of the localized neural network. This localized intelligence becomes a compounding asset for the company as the model evolves alongside the business, becoming more deeply integrated into the core digital transformation strategy over time. By maintaining the fine-tuning pipeline in-house, organizations eliminate the risk of their valuable trade secrets being used to improve the general models of their cloud competitors. Robust governance of the fine-tuning process ensures that all localized models adhere to the highest standards of digital trust and internal cybersecurity best practices for the enterprise. Absolute data governance is achieved by enforcing air-gapped deployments where the language model operates entirely within a secure internal network with no external connectivity to the open internet. This architectural choice eliminates the risk of third-party software as a service exposure and prevents the unauthorized exfiltration of sensitive information by malicious actors or external entities. Cybersecurity professionals advocate for zero-trust architectures that treat every internal request as potentially hostile while ensuring that localized intelligence remains isolated from the broader threat landscape. Implementing air-gapped AI requires a resilient infrastructure capable of handling the entire computational load of model inference without relying on external cloud processing or remote database access. Organizations operating in critical sectors like defense and energy utilize these isolated environments to leverage advanced reasoning capabilities while maintaining the highest levels of national and industrial security. The elimination of SaaS dependencies also provides a hedge against potential service outages and changes in vendor pricing models, ensuring continuous operational availability of critical AI-driven business processes. Managed service providers are now offering specialized hardware and software stacks designed specifically for the secure deployment and maintenance of localized intelligence in highly restricted or disconnected environments. Rigorous auditing of the air-gapped perimeter ensures that the sovereign AI remains at the protected asset while providing the necessary intelligence for enterprise transformation and long-term digital resilience. Validating the reasoning accuracy of small language models is essential for meeting the strict regulatory requirements of the legal and medical industries where precision is a non-negotiable factor. Systematic testing against domain-specific benchmarks ensures that the model can handle complex case studies and diagnostic inquiries with the necessary level of technical expertise and professional care. Compliance frameworks like those established by the European AI Alliance mandate that localized models demonstrate high reliability and transparency, especially when influencing outcomes in high-stakes professional sectors. Legal departments utilize these sovereign models to perform exhaustive contract analysis and litigation support while ensuring that all client attorney privilege remains protected within the internal corporate infrastructure. In the medical field, localized intelligence assists with clinical decision support by synthesizing vast amounts of patient data and research, while strictly adhering to privacy regulations and ethical guidelines. Accuracy validation involves a continuous feedback loop where human experts review model outputs to ensure that the reasoning remains aligned with established professional standards and current scientific knowledge. These sovereign systems provide the necessary audit trails and documentation required by regulators to prove that the AI is being used in a safe and responsible manner at all times. By prioritizing accuracy and compliance, organizations can confidently integrate localized language models into their most sensitive workflows without compromising their professional integrity or their adherence to the global law. Consider a global financial institution that successfully transitioned its data governance strategy by deploying a sovereign 14 billion parameter model within an entirely air-gapped internal server environment. This institution developed a robust pipeline to fine-tune the model on decades of proprietary transaction data and internal risk reports, creating a highly specialized intelligence for fraud detection. The localized model demonstrated higher reasoning accuracy than centralized cloud alternatives, while ensuring that every piece of sensitive financial information remained strictly within the bank-owned secured digital perimeter. By eliminating third-party exposure, the bank met all international regulatory requirements for data privacy while simultaneously reducing its operational costs by more than 40% through efficient model architecture. This practical implementation proves that localized intelligence can drive enterprise transformation while maintaining the highest standards of digital trust and cybersecurity for the most demanding global financial markets today. The integration of localized reasoning agents allowed the organization to automate complex compliance reporting tasks that previously required thousands of human hours each year to complete with absolute precision. Other organizations in the healthcare and legal sectors are now following this blueprint to build their own sovereign intelligence infrastructures that prioritize data sovereignty and professional ethics above all. This case study highlights the tangible ROI of the small language model movement, proving that sovereignty and performance can coexist through strategic neural architecture and disciplined infrastructure management. The future of enterprise AI lies in these localized deployments where the power of intelligence is combined with the security of total control over the organization's most valuable data assets. Strategic synthesis of localized intelligence requires a shift in leadership mindset from general cloud adoption toward a development of sovereign architectural capabilities as a core competitive advantage for 2026. The long-term trajectory of artificial intelligence points toward a multi-model environment where specialized small language models handle sensitive enterprise tasks while cloud models are used for generic functions. Achieving digital resilience in the era of exponential technology depends on the ability of an organization to build and maintain its own neural infrastructure independent of centralized cloud gatekeepers. This sovereign approach not only protects intellectual property, but also fosters a culture of innovation where the enterprise can rapidly adapt to new challenges through the continuous evolution of localized intelligence. Subscribe to at AI Knowledge is Power for deep dives into sovereign AI architectures and local infrastructure strategies that secure your organization's future. We walk the talk on digital trust. This content is 100% C2PA certified. Channel powered by generative AI architecture.